Hello guys, welcome back, PK here. So in this video, I'm working on this little challenging viewer-suggested integral, so stay tuned. Okay, here's the question. The question is evaluate this integral from 0 to infinity, ln square x times sine of x squared dx. For the sine of x squared part, this is Fresnel integral. So that's why we can let y as this x squared, which means x is now equal to square root of the y, and your dx is equal to dy now over 2 times square root of the y. Okay. So using this, then we can obtain 1 over 2 times integral from 0 to infinity. And then we have ln square root of the y. Okay, then that over square root of the y. Okay, then that times sine y and dy, right? Okay, now let's talk about this ln of square root of the y, right? Okay, this has to be the same as then ln of y to the power of 1/2. That is the same as then the 1 over 2 ln y. So using this, we can now obtain 1 over now 8 times integral from 0 now to infinity. And then we have ln square of just the y. That over y to the power of 1/2. Okay. And then that times sine of y, and we have now then dy. Okay, so based on this result, let me call IS. IS now then integral from 0 to infinity. And your integrand has to be just the y to the power of s minus 1. That times now sine y and dy. Okay, then if you plug it in 1 over 2 to your s, right? And I 1 over 2. This is going to be integral still from 0 to infinity. Okay, then your integrand has to be first of all 1 over square root of the y. And then that times sine of y, and we have now then dy. Okay, and then if you get your I prime of 1 over 2, I prime of 1 over 2 has to be then integral from 0 to infinity. Okay, then it has to be y to the power of 1 over 2 minus 1. Okay, and then that times now ln y. And then that times sine y and dy. Okay, so using this, let's talk about I prime of s. I prime of s has to be integral from 0 to infinity. Okay, then your integrand has to be y to the power of s minus 1. Okay, and then that times ln y times now the sine of y. Okay, then we have dy. Okay, then how about I double prime? So I double prime of s. Okay, this is going to be then integral from 0 to infinity. Okay, then your integrand has to be still y to the power of s minus 1. And then that times now ln y entire thing squared. That times now sine of y. And then we have dy. So that is why your I double prime of 1 over 2. If you plug it in 1 over 2 to your s, it should be the same as integral from 0 to infinity still. And then we have ln y entire thing squared over square root of the y. Okay, then that times now sine of y. And then we have dy. From this, what we want is 1 over 8 times I double prime of 1 over 2. This is what we wanted, right? Okay, then let's talk about I of s some more in details. So your I of s. I of s was integral from 0 to infinity. Then we have y to the power of s minus 1. And at that time, sine of y and dy. Right. This is going to be convergent if this s minus 1 is between negative 1 and 0, right? So from this, we can talk about this has to be the same as s is between 0 and 1. So this integral will be convergent when your s is between 0 and 1. Then at the same time, 1 over 2 is right in the middle between 0 and 1, right? So that's why now this I of s. I of s is now then integral from 0 to infinity. And we have y to the power of s minus 1. That times, we can actually work on complex analysis to rewrite the sine of y part. E to the power of iy minus e to the power of negative iy over 2I, right? So e to the power of iy minus e to the power of negative iy over now 2I. And of course, we have dy. Okay, so that's why if we rewrite this, then it has to be the same as 1 over 2I. That times integral from 0 to infinity. Then we have y to the power of s minus 1. And that times e to the power of iy. And then dy. Minus the same, still 1 over 2I. That times integral from 0 to infinity. And then your next integrand has to be still y to the power of s minus 1. And that times e to the power of negative iy. And then dy. Okay, from the previous result, let's change some variable. As this I, now y. Okay, as now negative z. Then at the same time, we'll be using gamma function to represent the previous result, right? Then we should be working on something like integral from 0 to infinity. And we have x to the power of m. And if we have now e to the power of I times x to the power of n, and we have dx. Okay. This is really useful expression. This has to be the same as now then 1 over n. And that times gamma of m plus 1 over n. That times e to the power of now I pi times m plus 1 over now 2n. Then our integral was integral from 0 to infinity. And then we have y to the power of s minus 1. And then that times e to the power of now I, y, and dy. One of them. This has to be the same as when your n is equal to now 1. And then your m is s minus 1. Okay, so that's why it has to be the same as the gamma of now the s times e to the power of I pi. Okay, then that times s over 2. Then at the same time, if you think about also this integral from 0 to infinity and y to the power of s minus 1 of e to the power of the other one was negative I, y, and dy. Okay. Then at the same time, in this case, your s has to be the real number. Okay, so if your s is a real number, then this gamma s, right? The gamma s is going to be the real, and also its complex conjugate too. So that's why the integral, we should be working on one of them, integral from 0 to infinity, y to the power of now then s minus 1. That times, okay, e to the power of iy dy. One of the integral we should be evaluating would be represented as now then this gamma of s. That times e to the power of now I pi times s over 2. Okay, this has to be the same as gamma of s. Okay, now that times now e to the power of negative I pi times s over 2 for that reason. And then if you think about this I of s, Okay, I of s is going to be then 1 over 2i. That times gamma s times e to the power of now then I pi now times s over 2. Okay, and then that minus 1 over 2i times gamma of s times e to the power of negative I pi times s over 2. Okay, so that is why your I of s. Now we can represent this I of s as the same as then gamma s times now sine of pi times this s over 2. Okay, so using this, let's talk about this I of 1 over 2. I of 1 over 2 has to be then gamma of 1 over 2. Okay, then that times sine of now then pi now over 4. This has to be the same as square root of the pi times now rad 2 over 2. Now let's talk about I prime of s, right? I prime of s has to be then gamma prime of 1 over now 2. Okay, then that times sine of now then pi times s over 2. Okay, then that plus gamma of now then s. Okay, then after that, we just multiply pi over 2 with cosine of still pi over 2 times s. So that's why your I prime of 1 over 2. Plug it in 1 over 2 to the s, right? Then we should have gamma prime of 1 over 2. That times sine of now then pi over 4. Then that plus, okay, that plus now gamma of 1 over 2. Okay, and then that times pi over 2 times cosine of pi over 4. Okay, then let's move on and talk about I double prime of s. So I double prime of s is then going to be gamma prime of s. Okay, then that times sine, then pi times s over 2. And then that plus 2 times gamma prime of the s. Okay, that times pi over 2 times cosine of pi times s over 2 still. And then minus gamma s times pi over 2 square. And then that times sine of now pi times s over 2 still. So that's why if you plug it in 1 over 2 to the s, I double prime of 1 over 2. Okay, that is now gamma prime of 1 over 2 times sine of pi over 4. Okay, and then that plus 2 times gamma prime of 1 over 2 times pi over 2 times cosine of pi over 4 minus gamma of 1 over now 2 times pi over 2 square times sine of pi over 4 again. So from this, let me use Legendre duplication formula, right? So using Legendre duplication formula. It is about gamma s times gamma s plus 1 over 2. That's going to be the same as now 2 to the power of 1 minus 2s. That times square root of the pi. And then that times gamma of 2 times s. Okay, so we can note. So in our case, here s is 1 over 2. Okay, and then gamma of 1 over 2 times gamma of 1 this is the same as square root of the pi times gamma of 1. So that's why gamma of 1 over 2 has to be just the same as square root of the pi. Okay, if you differentiate the result, then we will get gamma prime of s times now gamma of s plus 1 over 2. And then plus gamma of s times gamma prime of s plus 1 over now 2. Okay, this has to be the same as now then 2 to the power of 1 minus 2 times s. Okay, then that times now negative 2 ln 2. And then that times square root of the pi. Square root of the pi times now gamma of 2s. And then that plus 2 to the power of 1 minus 2s still. And then that times square root of the pi times gamma prime of now 2s times 2. Okay, and then if you plug it in, s is equal to 1 over 2. So at s is 1 over 2. Then you should be getting gamma prime of 1 over 2 times gamma of 1. Then that plus square root of pi times gamma prime of 1. Okay, this is going to be just equal to, okay, so negative 2 ln of now then 2. That times square root of the pi, okay, that times now gamma 1. And then that plus square root of pi times gamma prime of 1 times 2. Okay, so now your gamma 1 is just equal to 1. And then gamma prime of 1 is this little gamma, which is Euler's matrimony constant, right? So that's why your gamma double prime of 1 is just equal to this little gamma square plus pi square over now 6. So that's why now gamma prime of 1 over 2. This is going to be equal to negative 2 times ln now 2. Okay, then that times square root of the pi, and then minus little gamma times square root of the pi. Okay, so in order to compute this double prime gamma of 1 over 2, right? Okay, then we should differentiate one more time. If you go ahead and do this, then it should have, okay, gamma double prime of now s times gamma of s plus 1 over 2. And then that plus, okay, then 2 times gamma prime of now s times gamma double prime of now s plus 1 over now 2. Okay, then that plus gamma of s, okay, and then that times gamma prime of s plus 1 over 2. Okay, so what we just wrote down right here, this has to be the same as 2 to the power of 1 minus 2s, right? And then that times negative 2 times ln now 2. Okay, then we should square this times square root of now then pi. That times gamma of 2 times s. Okay, and then that plus now 2 times 2 to the power of 1 minus 2s. Okay, then after that, we have still this negative 2 ln 2 to be multiplied, and that times now square root of the pi times gamma now prime of 2s times now 2. And then we have one more term, right? So we have one more term that is plus 2 to the power of 1 minus 2s. Okay, then that now times square root of pi, and that times now gamma. Okay, so we should have gamma double prime of 2s times now 2. Okay, so this is what we have, right? And then we should be plugging in 1 over 2 to the s, right? Just to get the value of gamma double prime of 1 over 2. So that's why s is equal to 1 over 2. And then that is going to be now then gamma double prime of 1 over 2. Now plus, let me pull this 2 out and make a parenthesis. And inside we should have negative 2 ln now 2. That times now square root of the pi. Okay, and minus little gamma times square root of the pi. Okay, and then that close your parenthesis and multiply, okay, negative little gamma. Okay, then that plus square root of the pi times little gamma square plus pi square over now 6. Okay, so let's keep working on this expression, right? So this has to be the same as then negative 2 ln 2, entire thing square. That times square root of the pi, okay, that minus 8 times ln 2 times now square root of pi times negative little gamma. Then that plus 4 times square root of the pi times little gamma square plus this pi square over 6. So that is why double prime of gamma 1 over 2. This is going to be equal to now then 4 times ln square of 2 times square root of the pi. And then that plus now 4 ln now 2 times square root of the pi times little gamma. And then that plus now square root of the pi times little gamma square plus square root of the pi times pi square over 6. Okay, then we already know this gamma 1 over 2. This was square root of the pi, right? And then we do have the value of gamma prime of 1 over 2. That was now negative 2 times ln 2 times square root of the pi, and then minus little gamma times square root of the pi. So that's why the integral that we are looking for, from 0 to infinity, ln square x times sine x squared dx. Okay, this is going to be the same as 1 over 8 I double prime of 1 over 2. So that's why it has to be the same as 1 over 8. That times square root 2 over 2. And let me make a parenthesis that we have gamma double prime of 1 over 2. And then plus 2 pi over 2 times gamma prime of 1 over 2. And then minus pi over 2 squared times now square root of the pi. Close your parenthesis. So that's why if you multiply these two, then we should have square root of the 2 times over 16 and parenthesis double prime of gamma 1 over 2 now plus just a pi. Pi times now gamma prime of 1 over 2. And then that minus pi to the power of 5 over 2. Okay, that over now 4. This would be the answer for the question. Okay, so pretty interesting but a little challenging integral. So I'll be back with more videos, more questions like this sometime soon.